By the year 2070, 3 billion people will live in zones of heat that by today's standards, we would consider uninhabitable for long periods of the year. But here's something even more remarkable. In March 2022, areas of the Arctic were 50 degrees Fahrenheit warmer than average, and regions around the North Pole were nearly melting. Most of us didn't notice. We went to work. We lived our lives. The invisible threshold was already beginning to open beneath our feet. Before we start, a quick roll call. Write in the comments which part of this planet you're watching from, and then just listen and enjoy. The question we're exploring today is deceptively simple. What changes are already locked into our future, and which ones can we still shape? By the time your grandchildren reach adulthood in 2070, they will inherit an Earth transformed not by sudden catastrophe, but by the patient, relentless mathematics of atmospheric physics. Understanding this distinction between fear and knowledge is where we begin. In January 2023, researchers at Stanford University published something that shifted the conversation about our climate future. They used artificial intelligence, a neural network trained on thousands of climate simulations, to predict when Earth would cross specific temperature thresholds. The AI wasn't guessing. It was reading patterns in current temperature data from around the world. Patterns that emerge from the physics of how heat moves through our atmosphere and oceans. And what it found was this. Regardless of how much we reduce emissions in the coming decade, the world is on track to reach 1.5 degrees Celsius of warming above pre-industrial levels in the early 2030s. That's within 10 years from now. Not in your grandchildren's time, in yours. This matters because we're not talking about abstract numbers. The Earth is already 1.1 degrees warmer than it was before we began burning fossil fuels at scale. That single degree has already given us more frequent wildfires, more extreme rainfall and flooding, longer and more intense heat waves. Every fraction of a degree intensifies these consequences. And the Stanford study revealed something more unsettling. If we don't reach net zero emissions until around 2076, which is actually faster than current global policies suggest, there's still a 50% chance we'll hit 2 degrees of warming by 2054. By 2060, the probability rises to more than 4 in 5. Here's why this challenges previous assumptions. The Intergovernmental Panel on Climate Change, the world's most authoritative climate assessment body, had suggested that 2 degrees was unlikely if emissions declined to net zero before 2080. But the AI, looking at the actual state of the climate system right now, tells us something different. According to Stanford climate scientist Noah Diffenbaugh, who led the study, the AI is quite convinced that there has already been enough warming that 2 degrees Celsius is likely to be exceeded if reaching net zero emissions takes another half-century. In other words, the warming we've already baked into the system through decades of emissions that have already happened may carry us further than we thought. This isn't prophecy. This is physics reading its own trajectory. Now let's talk about something that sounds abstract, but carries immense symbolic and practical weight. The Arctic Ocean's first ice-free day. For as long as humans have kept records, the Arctic has been covered by sea ice and snow year-round. It's one of the defining characteristics of our planet's natural environment. But research published in late 2024 suggests we could see the Arctic Ocean's first ice-free day as early as 2027, potentially within 3 years from that study's publication. Scientists define ice-free as when the Arctic Ocean has less than 1 million square kilometers of ice coverage. Right now, Arctic sea ice is melting at an unprecedented speed of more than 12% each decade. Using output from over 300 computer simulations, researchers Alexandra Jean from the University of Colorado Boulder and Céline Houzé from the University of Gothenburg found that most models place the first ice-free day within 9 to 20 years after 2023, regardless of how humans alter greenhouse gas emissions. 9 simulations suggested it could happen in 3 to 6 years. The mechanism is understood. A series of extreme weather events, an unusually warm autumn that weakens sea ice, followed by a warm Arctic winter and spring that prevents new ice from forming, could melt 2 million square kilometers or more in a short period. When the Arctic experiences such extreme warming for 3 or more years in a row, that first ice-free day becomes possible in late summer. And we've already seen years like these. The March 2022 event I mentioned at the start wasn't an anomaly. It was a preview. Why does this matter beyond symbolism? Because sea ice protects the Arctic from warming by reflecting incoming sunlight back into space. With less reflective ice, darker ocean waters absorb more heat from the sun, further increasing temperatures not just in the Arctic, but globally. This is what scientists call a feedback loop, a self-reinforcing cycle where warming creates conditions that cause more warming. Additionally, warming in the Arctic can alter wind and ocean current patterns, leading to more extreme weather events around the world. The Arctic doesn't stay in the Arctic. But here's what's crucial to understand. These projections are not sentences of doom. They are measurements of momentum. Jean herself noted that while the first ice-free day shouldn't change things too dramatically, it represents a fundamental alteration of one of Earth's defining characteristics. It's a threshold that shows we've changed something permanent. And yet there remains what she calls a small window of hope. Drastic cuts in greenhouse gas emissions now could delay the timeline for an ice-free Arctic and reduce the time the ocean stays ice-free. As John stated simply, any reductions in emissions would help preserve sea ice. This is the landscape we're standing in as we look toward 2070. We are crossing invisible thresholds that carry visible consequences. Scientists gathered at the second Global Tipping Points Conference in July 2025 discussed how many climate tipping points could be crossed between 1.5 and 2 degrees of warming. The Ross Ice Shelf, for instance, was shown to tip between 3.5 and 4 degrees Celsius, while some scientists hypothesize that certain ocean circulation patterns may have already crossed tipping points. Multiple tipping points are likely to be triggered if global policies stay on their current course. And as Professor Tim Lenton from Exeter's Global Systems Institute warned, crossing these thresholds could have devastating consequences for humanity. Yet the same research that identifies these risks also identifies the margin where human choice still matters. It will be decided in the coming decades whether these tipping points are crossed or not. The trajectory is not fixed. It is responsive to what we do now. So what will 2070 look like? Your grandchildren will live on a planet that is measurably, dramatically warmer than the one you grew up on. They will live in a world where the Arctic experiences ice-free days or even months each summer. They will navigate weather patterns altered by changes we set in motion decades before they were born. But they will also inherit every innovation, every adaptation, every choice we make between now and then. The threshold is invisible, not because it's unreal, but because it unfolds gradually, degree by degree, year by year, decision by decision. We have very clear evidence of the impact from the 1 degree Celsius of warming that has already happened. This new evidence, using new methods, adds to our understanding that we will certainly face continuing changes in climate that intensify the impacts we're already feeling. The question isn't whether 2070 will be different. It will be. The question is how different, and whether that difference lands within the range where human civilization can adapt or beyond it. This is the invisible threshold. We're crossing it now. Your grandchildren will live on the other side. In 2070, Europe's population will represent just 4% of the world's total. For comparison, in the mid-20th century, Europeans made up around 15% of global population. But this isn't just about numbers shrinking. It's about the entire architecture of society transforming so fundamentally that the way we live, work, and care for each other will operate by rules we're only beginning to understand. Let's start with something simple. Children. In the European Union right now, the average fertility rate stands at about 1.5 children per woman. To maintain a stable population, you need 2.1. This gap has persisted for decades, and its consequences are unfolding slowly but inexorably. By 2050, 1/3 of Europe's population will be over 65 years old. Today, that proportion is around 21%. This isn't just a statistical shift. It's a fundamental rewiring of how society functions. Imagine this. For every 3 working people, there's 1 retiree needing not only income, but care, medical support, social services. Currently, the working age population makes up about 64% of Europeans. By 2070, that will fall to around 54%. Fewer hands will support more people. Fewer builders, teachers, nurses, producers, innovators. An economic system built on steady growth in consumers and workers will face the reality of a shrinking labor force. But the fastest growing demographic is people over 85. Their share will more than double from 3% now to 6% by 2050, and nearly 8% by 2070. These are people who will need long-term care, specialized medical attention, infrastructure adapted to their needs. And the pool of people capable of providing that care will be contracting. Today, Europe's long-term care sector relies heavily on informal caregiving. That is, family care, often provided by women. But when the number of people needing care doubles, while the number of potential caregivers shrinks, that model breaks. We'll need professional care systems, new technologies, robotic assistance, an entirely different approach to organizing elder life. There's a bright side to this process. By 2070, life expectancy in developed countries is projected to reach 90 years for women and 86 for men. Over the past 50 years, European life expectancy has increased by around 10 years on average. We're living longer and staying healthier longer. Old age in 2070 will not resemble old age in the 20th century. A 70-year-old in 2070 will likely be more active, healthier, more engaged in society than their counterpart today. But this doesn't cancel the basic mathematics. Fewer young, more old, fewer workers, more needing support. Now let's zoom out to the global picture. While Europe ages and shrinks, the planet's population continues growing, though at a decelerating pace. By 2070, the world will have around 10 billion people, but the distribution of that population will change dramatically. India, and China will remain the most populous nations. But China began shrinking in 2022, and by century's end, its population could fall below 800 million, nearly half what it is today. India will peak at around 1.5 billion by 2060, then begin declining too. Meanwhile, Nigeria will enter the top 10 countries by population with 546 million people by 2100, alongside Pakistan, the Democratic Republic of Congo, Ethiopia, Tanzania. Africa will become the continent of youth and growth, while Europe and East Asia become continents of age and decline. This isn't merely demographic fact. It's a shift in global centers of economic activity, innovation, cultural influence. Russia, according to projections, will remain Europe's most populous country by 2100, but will rank only 20th globally with 112 million people. Eastern Europe overall will face particularly sharp population decline. Lithuania, Latvia, Ukraine, Bulgaria, Serbia, these countries are forecast to lose more than 20% of their population by 2050. The reason is twofold: low birth rates and high emigration of young, skilled professionals. This is called brain drain, and it intensifies the demographic crisis because the very people who leave are those who might have birthed the next generation. In Western and Northern Europe, the picture softens somewhat. Austria, Spain, Sweden, Belgium, Ireland, the Netherlands. These countries are expected to see population growth through 2050 thanks to immigration. France and Germany will balance on the edge of zero growth. Natural population decline offset by migration. But even here, the population structure will change radically. Immigrants arriving in Europe won't simply fill job vacancies. They'll shape the cultural, social, political character of the continent. How successfully these newcomers are integrated into labor markets, education systems, civic life will determine the stability of European societies in 2070. There's another trend spoken of less, but one that will alter the fabric of daily life: the rise of single-person households. Today, in the European Union, there are more than 70 million one-person households, the fastest-growing household type. By 2070, living alone will be not the exception, but increasingly the norm. This has profound implications. Who cares for the sick when there's no spouse, no children nearby? How do cities design housing when most dwellings need to accommodate only one person? What happens to social cohesion when the basic unit of society shifts from family to individual? Yet, there are solutions emerging. Multi-generational living is being reimagined. Not the traditional model where children care for aging parents out of obligation, but intentional communities where young and old live together by choice, sharing resources, knowledge, companionship. Co-housing projects are spreading across Northern Europe, where residents have private spaces, but share kitchens, gardens, workshops. Technology is enabling elderly people to live independently longer through smart home systems, telemedicine, wearable health monitors. And there's a deeper question here about what we value. For centuries, economic growth was tied to population growth. More people meant more workers, more consumers, more innovation. But 2070 will test whether prosperity can exist in a world of demographic decline. Japan is already pioneering this experiment. Its population has been shrinking since 2011, yet it remains one of the world's wealthiest, most technologically advanced nations. The challenge isn't whether prosperity without growth is possible. It clearly is. The challenge is managing the transition without social collapse. The workforce implications are immense. Eastern and Southern Europe will face severe labor shortages, undermining competitiveness and potentially widening inequality within the EU. Western and Northern countries will age too, but slower natural decline and larger migration flows give them more time to adapt. Still, regional disparities within countries will likely widen as migrants concentrate in cities, leaving rural areas even more vulnerable to depopulation. Policies must adapt. Eastern countries need to focus on retaining talent, attracting migrants in sectors with shortages, increasing labor force participation among women and older workers. Southern countries should strengthen family-friendly and youth employment policies while improving migrant integration. Western and Northern countries must prioritize migrant integration, rural development, gradual labor market reforms for aging populations. Here's the reality your grandchildren will inherit: a Europe that is older, smaller, more diverse, and more unequal between regions than anything we've known. The median age of Europeans will reach around 50 years by 2070, up from 44 today. In some countries, half the population will be over 50. The ratio of very old people, those over 85, to working age people will rise from about 3% now to around 15 to 18% by 2070 in many regions. This is the demographic metamorphosis, not collapse, not catastrophe, transformation. And like all transformations, it carries both danger and possibility. The danger is clear: systems designed for growth, failing under contraction. Intergenerational conflict over resources, regions left behind. The possibility is equally clear: societies that value quality of life over endless expansion. Communities built on interdependence rather than isolation. Technologies that extend healthy life far beyond current limits. Your grandchildren won't recognize this aspect of Earth in 2070 because the people around them will look, sound, and live differently than the people around you today. The question isn't whether that change is coming. It's already here. The question is whether we shape it wisely. Between now and 2070, the total urban area on Earth will double. Think about that for a moment. Every city street, every apartment building, every park and plaza that exists today across the entire planet, all of it will be matched by an equivalent amount of new urban construction within the next 45 years. This isn't growth. This is metamorphosis. But here's what's remarkable. The cities your grandchildren will live in won't simply be bigger versions of what we have now. They'll operate on entirely different principles. The car-dependent sprawl that defined the 20th century, the endless suburbs, the highways cutting through neighborhoods, the necessity of driving everywhere, is dying. Not because of regulation or ideology, but because it doesn't work. It's expensive, inefficient, unhealthy, and unsustainable. And the cities emerging now, the ones that will mature by 2070, understand this. The concept reshaping urban planning is called the 15-minute city, or what some European planners refer to as cities of short distances. The idea is elegant. Everything you need for daily life, work, education, healthcare, recreation, shopping, should be accessible within a 15-minute walk or bike ride. Not in some neighborhoods, in all neighborhoods. This isn't nostalgia for village life. It's sophisticated urban design that recognizes what makes human beings thrive. Barcelona pioneered the superblock model, where clusters of 9 blocks prioritize pedestrians and cyclists, restricting car traffic to the perimeter. The interior streets transform into green corridors, play spaces, outdoor markets. Paris has committed to becoming a 15-minute city by 2030, reshaping the entire urban fabric around proximity rather than mobility. Helsinki is building entire new districts where car ownership is unnecessary by design. These aren't experimental projects anymore. They're blueprints being replicated globally. By 2070, this will be the norm, not the exception. Your grandchildren will likely not own cars. They won't need to. Their cities will be dense but spacious, vertical but green. Buildings will rise higher, yes, but between them will be parks, gardens, community spaces. Rooftops will host urban farms and solar panels. Ground floors will buzz with local businesses, workshops, clinics, schools. The distinction between residential and commercial zones, the zoning logic that created dead downtowns and soulless suburbs, will have dissolved. This transformation is driven partly by climate necessity. Dense, walkable cities produce far less carbon emissions per person than sprawling ones. But it's driven equally by demographic reality. Remember the aging, shrinking populations we discussed? In Europe especially, where the working age population will drop significantly, there simply won't be enough people or resources to maintain the sprawling infrastructure of the 20th century. Highways require maintenance. Sprawl requires services. Dispersed populations require expensive transportation networks. None of this scales down gracefully. So cities are contracting their footprints while increasing their density. This is already happening in parts of Eastern Europe and the Rust Belt of America. By 2070, it will be standard practice. Cities will define clear boundaries beyond which urban services won't extend. Inside those boundaries, density will increase, but in human-scaled ways. Instead of isolated skyscrapers surrounded by parking lots, you'll see neighborhoods of mid-rise buildings, 6 to 10 stories, that create street-level vitality while housing many people in small geographic areas. The Irish Cities 2070 initiative, for example, explicitly calls for this model. Compact neighborhoods as the building blocks of future urban life. Infrastructure must precede development, not follow it. This reverses the typical pattern where housing sprawls outward and infrastructure struggles to catch up. Instead, cities will plan transit lines, water systems, energy grids first, then allow development only where those systems exist. This creates efficient, livable density rather than chaotic sprawl. Water will define cities in ways we're only beginning to understand. With sea levels rising 20 to 56 centimeters by 2070, depending on emission pathways, coastal cities face fundamental choices: retreat, defend, or adapt. Some will build massive seawalls, as the Netherlands has done for centuries. Others will embrace amphibious architecture, buildings designed to float or flex with water levels. Still others will surrender certain areas to the sea and relocate populations inland. But it's not just coastal cities. Everywhere, water management will shift from drainage to absorption. Traditional cities treat rainwater as a problem to be channeled away as quickly as possible. Future cities will treat it as a resource to be captured and used. Green roofs, permeable pavements, urban wetlands, rain gardens. These aren't decorative flourishes. They're infrastructure. They cool cities during heat waves, filter air pollution, recharge groundwater, prevent flooding, and provide habitat for wildlife. Singapore is already there. The city-state captures nearly every drop of rainwater, treats it, and uses it By 2070, most cities will operate similarly because climate change is making rainfall more erratic. Long droughts punctuated by intense storms. Cities that can't manage water won't survive. Energy systems will be decentralized. Instead of massive power plants far away feeding cities through vulnerable grids, buildings will generate much of their own power through rooftop solar and building integrated photovoltaics. Neighborhoods will form microgrids that can operate independently during emergencies. Battery storage will smooth the intermittency of renewable energy. District heating and cooling systems will recycle waste heat from one building to warm another. This isn't just environmentalism, it's resilience. Centralized systems have single points of failure. Decentralized systems are anti-fragile. They get stronger under stress because damage to one part doesn't cascade through the whole system. Transportation will look radically different. Self-driving electric vehicles will dominate, but most won't be owned individually. They'll function as fleets, shared autonomous vehicles summoned by app when needed. This reduces the number of vehicles dramatically. Studies suggest cities could operate with 10% of current vehicle numbers if cars were shared efficiently. That frees enormous amounts of space currently devoted to parking. In American cities, parking lots occupy nearly a third of urban land. Imagine reclaiming that for housing, parks, community centers. But personal vehicles will still be less important than public transit. High-speed rail will connect cities across continents. Electric buses, trams, and subways will move efficiently through dense urban cores. Bike infrastructure will be comprehensive and protected, not an afterthought. Walking will be pleasant, safe, and direct because streets will be designed for people, not cars. This is where smart cities either succeed or fail. There's a temptation to think technology alone solves urban problems. Sensors monitoring everything, algorithms optimizing traffic flow, apps managing every interaction. That's a mirage. Technology is a tool, not a solution. The cities that thrive in 2070 will be wise cities, not just smart ones. They'll use technology to enhance human connection, not replace it. They'll prioritize social cohesion, equity, beauty, and delight, not just efficiency. Copenhagen demonstrates this. It's among the world's most livable cities, not because it's the most high-tech, but because it balanced technology with humanity. It invested in cycling infrastructure, public spaces, social housing, renewable energy, and democratic urban planning. The result is a city with high quality of life, low carbon emissions, and resilient communities. By 2070, your grandchildren will likely live in cities that feel simultaneously ancient and futuristic. Ancient because they'll prioritize the human scale, mixed-use neighborhoods, walking, face-to-face interaction, patterns that have defined successful cities for millennia. Futuristic because the materials, energy systems, information infrastructure, and governance models will be radically advanced. Buildings will be constructed from engineered timber, massive wooden structures that sequester carbon rather than emitting it like concrete and steel. Facades will clean air, generate power, shift with seasons to maximize natural light and temperature control. Vertical gardens will climb building faces, providing insulation, food, and beauty simultaneously. Public spaces will be the heart of these cities. Plazas, parks, community gardens, outdoor theaters. These aren't luxuries, but necessities for social health. The loneliness epidemic we're experiencing now, where single-person households proliferate and social bonds weaken, can't continue. Cities of 2070 will deliberately design spaces that bring people together across ages, backgrounds, and circumstances. There will be failures and disparities. Not every city will transform successfully. Some will remain car-dependent, sprawling, inefficient. Wealthy neighborhoods will access the best infrastructure while poor ones struggle. Climate refugees will strain urban systems in ways that test social cohesion. Rapid densification will sometimes erase history and character in the name of efficiency. But the trajectory is clear. By 2070, cities will either breathe, meaning they'll be integrated with nature, responsive to human needs, resilient to shocks, beautiful and livable, or they'll suffocate under the weight of outdated systems designed for a world that no longer exists. Your grandchildren won't recognize cities in 2070, not because they'll be alien, but because they'll have rediscovered what cities were always meant to be. Dense concentrations of human possibility organized around connection rather than separation, around life rather than machines. The city as living organism, the city that breathes. Stand on any coastline today, and what you see is temporary. The boundary between land and sea that has defined human civilization for millennia is moving. Slowly, yes. Quietly, certainly, but inexorably. By 2070, sea levels will have risen between 20 and 56 centimeters, depending on the emissions pathway we follow. That might not sound dramatic. It's less than 2 feet at the high end. But here's what those centimeters mean. Hundreds of millions of people displaced. Trillions of dollars in coastal infrastructure underwater. Entire island nations questioning their existence, and a fundamental psychological shift in how humanity relates to the ocean. We've always thought of the sea as staying in its place. Our maps showed clear borders. We built ports, cities, airports, industrial facilities right at the water's edge, because that edge seemed permanent. Your grandchildren will inherit a world where that assumption is dead. Let's be precise about what we know. The projections for sea level rise by 2070 range from about 20 centimeters in the most optimistic scenario, where global emissions drop dramatically and quickly, to 56 centimeters or more if emissions continue on current trends. These numbers come from complex models that account for thermal expansion of warming ocean water, melting ice sheets in Greenland and Antarctica, and glacier melt worldwide. The science is robust. The uncertainty isn't whether seas will rise, but how fast and how far. But sea level rise is just one dimension of ocean transformation. Ocean surface temperatures are projected to increase by 1.1 to 2.3 degrees Celsius by 2070 in most regions. That might seem modest, but oceans are enormous heat reservoirs. A 1 degree increase represents an almost incomprehensible amount of energy absorbed. Warmer oceans fuel stronger hurricanes, alter marine ecosystems, disrupt fisheries that billions depend on for protein, and accelerate the melting of polar ice from below. Then there's ocean acidification, the less visible twin of climate change. As the ocean absorbs carbon dioxide from the atmosphere, it becomes more acidic. Since the Industrial Revolution, ocean acidity has increased by 30%. By 2070, depending on emission pathways, it could increase another 50 to 100%. This isn't abstract chemistry. It's the dissolution of coral reefs, the collapse of shellfish populations, the disruption of the entire marine food web from the microscopic organisms at its base upward. Coral reefs support a quarter of all marine species and provide livelihoods for 500 million people. Most will be gone, or severely degraded by 2070 under current trajectories. Now zoom into specific places: Miami, Venice, Bangkok, Shanghai, Lagos, Dhaka. These are among the world's most vulnerable megacities. Miami's average elevation is less than 2 meters above current sea level. Much of the city sits on porous limestone, which means seawalls don't work. Water seeps up from below during high tides. Even with moderate sea level rise, Miami as we know it becomes increasingly difficult to inhabit by 2070. Some neighborhoods will flood regularly. Salt water will contaminate freshwater supplies. Infrastructure will corrode. Property values will collapse in vulnerable zones, triggering economic cascades. Bangladesh presents a more acute crisis. Much of the country sits barely above sea level in the Ganges-Brahmaputra Delta. With 56 centimeters of sea level rise, combined with more intense cyclones and storm surges, tens of millions of people will be displaced by 2070. Where do they go? This isn't a hypothetical. It's a planning question that South Asian governments are already grappling with. Climate migration will be one of the defining humanitarian challenges of the mid-21st century. Island nations face existential questions. The Maldives has an average elevation of 1.5 meters. Tuvalu, Kiribati, the Marshall Islands, these aren't just losing land. They're losing identity, sovereignty, culture. By 2070, some may be entirely submerged during storm surges, uninhabitable even if technically above water at low tide. Where do populations go when their entire nation disappears? What does it mean legally, diplomatically, psychologically, when a country ceases to exist geographically? But this story isn't just about loss. It's also about adaptation, innovation, and the remarkable human capacity to live with water rather than against it. The Netherlands has been doing this for centuries. With much of the country below sea level, the Dutch pioneered sophisticated systems of dikes, pumps, and controlled flooding zones. Now they're exporting this expertise globally. But even the Netherlands is evolving its strategy. Instead of just building higher walls, they're creating amphibious architecture, houses that float on foundations when water rises, neighborhoods designed to flood temporarily without catastrophic damage, parks that double as water storage during storms. This is happening in Rotterdam, where public squares are designed as basins that fill during heavy rains, preventing flooding elsewhere. Playgrounds sit in shallow bowls that collect water. When the rain stops, the water drains away and children return. This is infrastructure that works with water, not against it. Copenhagen has embraced a similar philosophy with its cloudburst management plan. Instead of building ever larger underground pipes to channel rainwater away, the city redesigned streets and parks to absorb and slow water during extreme rainfall events. Streets become temporary rivers with controlled flow. Parks become detention ponds. The system is beautiful, functional, and far more resilient than traditional drainage infrastructure. Singapore is taking this to the extreme. The island nation has almost no natural fresh water and depends on imports from Malaysia. To achieve water independence, Singapore now captures nearly all rainfall, treats wastewater to drinking standard, and even desalinates seawater. By 2070, these technologies will be standard in water-stressed regions worldwide. When you can't rely on stable rainfall patterns or aquifers, you engineer systems that capture every drop and use it multiple times. Floating cities are no longer science fiction. The Maldives is developing floating urban platforms, modular structures that rise and fall with sea levels, connected by flexible walkways. These aren't houseboats. They're engineered neighborhoods with housing, shops, parks, utilities designed to accommodate thousands of people. By 2070, floating architecture may house millions, particularly in Asia, where population density and flood risk intersect most acutely. Then there's managed retreat, the strategy nobody wants to discuss openly, but that's increasingly unavoidable. Some places simply cannot be defended affordably. Coastal communities in the United States are already relocating. The town of Shishmaref in Alaska voted to relocate inland as permafrost melts and erosion accelerates. Ile de Jean Charles in Louisiana, a Native American community, received federal funding to move as land disappears beneath the Gulf of Mexico. By 2070, managed retreat will be commonplace. Governments will buy out properties in high-risk zones and return land to marshes and wetlands that naturally buffer storm surges. This is painful. It means abandoning homes, communities, memories, but it's also pragmatic. Maintaining infrastructure in areas destined to flood repeatedly becomes economically irrational. Better to move populations proactively with dignity and resources than reactively during disasters. The psychological dimension matters as much as the physical. Humanity has always drawn security from stable landscapes. We build permanence into our cities, our homes, our sense of place. A world where coastlines shift, where infrastructure must be temporary or mobile, where entire regions become uninhabitable. This challenges our fundamental relationship with geography. Your grandchildren will need to develop what researchers call climate resilience, not just in infrastructure, but in mindset. The ability to adapt, move, rebuild, and accept impermanence as normal. There's another shift happening beneath the surface, literally. The ocean ecosystems your grandchildren inherit will be profoundly different from today's. Warmer, more acidic waters favor different species. Tropical fish are migrating toward poles. Kelp forests are dying in warming waters. Coral reefs are bleaching and not recovering. Commercial fisheries are shifting, sometimes collapsing. By 2070, the geography of marine life will have redrawn itself. Fishing communities that have harvested the same waters for generations will find those waters empty of familiar species. But again, adaptation emerges. Aquaculture, fish and seaweed farming, is expanding rapidly and will provide a growing share of global protein by 2070. Done sustainably, it's far less resource-intensive than land-based meat production. Kelp farming in particular is promising. Kelp grows incredibly fast, absorbs carbon, doesn't require fertilizer or fresh water, and can be used for food, animal feed, and bioplastics. By 2070, massive kelp farms may line coasts, providing food while mitigating climate change. The economics of all this are staggering. Coastal property worth trillions of dollars will lose value as flood risk becomes uninsurable. Insurance companies are already withdrawing from high-risk areas. By 2070, the real estate map will have fundamentally redrawn itself. Inland property appreciates, coastal property depreciates. Entire cities reorganize around new assumptions about water. Yet opportunity exists too. New ports will emerge in the Arctic as ice retreats, opening northern shipping routes. New coastlines will appear, new fisheries, new possibilities. Humanity has always clustered at water's edge, because water means trade, food, transportation, life. That won't end. But which edges we cluster at will change. Here's the essential truth your grandchildren will live with. The ocean is not the enemy. It's responding to the physics of a warming planet with perfect neutrality. The water rises because ice melts and warm water expands. No malice, no mercy, just thermodynamics. How we respond, whether with wisdom or denial, innovation or rigidity, equity or abandonment, will determine whether this transformation is managed or chaotic. By 2070, the maps will be different. Some coastlines will have retreated. Some cities will be partially abandoned or transformed into Venice-like canal networks. Some nations will have relocated populations wholesale, but humans will still live by the water because we always have and always will. We'll just do it with eyes open to impermanence, with infrastructure designed for flux, with the humility to accept that the boundary between land and sea was never really ours to dictate. The water world rises, not to punish us, but to teach us that Earth was never static. We just pretended it was. Your grandchildren will never know what it's like to be alone with their own thoughts. Not in the way you do. By 2070, artificial intelligence will be so deeply woven into the fabric of daily existence that the boundary between human thinking and machine assistance will become nearly imperceptible. This isn't dystopia. It's not utopia either. It's simply a different condition of being human, one where intelligence is augmented, mediated, and extended by systems that think alongside us rather than merely serve us. Let's start with what's already happening. Right now, AI systems can diagnose certain diseases more accurately than experienced doctors. They can translate languages in real time, generate coherent text, compose music, create artwork, drive cars, play complex strategy games better than any human, and predict protein structures that have eluded scientists for decades. These aren't future capabilities. They exist today. By 2070, these will seem as primitive as a steam engine seems to us now. The question isn't whether AI will be ubiquitous by 2070. It will. The question is how that ubiquity reshapes human capability, purpose, and identity. Consider work first, because that's where the transformation will be most visible. By 2070, most tasks currently performed by humans in structured environments, data entry, routine analysis, scheduling, basic customer service, much of manufacturing, even significant portions of legal research, accounting, and medical diagnostics will be automated. Not eliminated, but transformed. The pattern we're seeing emerge is that AI excels at pattern recognition, optimization, and processing vast amounts of information quickly. What it struggles with, and will likely continue to struggle with even in 2070, is genuine creativity, complex human interaction, ethical judgment in ambiguous situations, physical work in unpredictable environments, and tasks requiring deep contextual understanding that spans many domains. So your grandchildren's work won't disappear. It will shift. Jobs that involve creativity, caregiving, strategic thinking, teaching, emotional intelligence, and solving novel problems will remain fundamentally human. But many of the routine, repetitive cognitive tasks that currently fill much of our workdays will be handled by AI systems. This creates both opportunity and disruption. The opportunity is liberation from drudgery. Imagine never having to do a repetitive task again, never wasting time on bureaucratic paperwork, never getting lost in administrative overhead. The disruption is that millions of people currently employed in jobs that can be automated will need to transition to new roles. How smoothly that happens depends entirely on decisions made between now and then about education, retraining, social support systems, and how we distribute The economic gains from automation. Here's a concrete example. Healthcare. By 2070, AI diagnostic systems will likely surpass human doctors in pattern recognition, detecting subtle signs of disease in medical images, identifying rare conditions from symptoms, predicting which patients are at risk of complications. But medicine isn't just diagnosis. It's communication, empathy, ethical decision-making in ambiguous situations, helping patients navigate fear and uncertainty. These remain profoundly human tasks. So the physician of 2070 will work in partnership with AI systems that handle the pattern matching, while the human brings judgment, compassion, and contextual understanding. The AI becomes a diagnostic co-pilot, freeing the doctor to be more human, not less. Education will transform similarly. By 2070, personalized AI tutors will be available to every student, adapting in real time to individual learning styles, pacing instruction perfectly, providing infinite patience and customized explanations. This could be revolutionary for equity. Every child, regardless of geography or family income, could access world-class instruction tailored specifically to their needs. But again, the human teacher doesn't disappear. Teachers become mentors, guides, coaches focused on motivation, socialization, critical thinking, and helping students develop the uniquely human capacities that AI can't replicate: curiosity, resilience, ethical reasoning, collaboration. Now let's talk about something more subtle: the end of going to work as we know it. The pandemic of 2020-2022 demonstrated that enormous amounts of knowledge work can happen remotely. By 2070, that transition will be complete for most cognitive labor. Your grandchildren will likely never commute to an office 5 days a week unless they choose to. Work will happen in distributed networks, some from home, some from shared community workspaces, some from anywhere with connectivity. The geographic tethering of people to job locations will weaken dramatically. This has profound implications. People won't need to cluster in expensive cities to access career opportunities. Rural and suburban areas could revitalize as economic centers in their own right. Families could live near extended relatives instead of relocating for jobs. Or conversely, people could become even more nomadic, working from anywhere with good internet. Either way, the rigid model of the 20th century, live where the job is, will dissolve. But there's a shadow side. Remote work, mediated by AI tools, can also be isolating. Humans evolved for face-to-face interaction. When most communication is digital, when AI handles scheduling and coordination, when you rarely see colleagues in person, maintaining genuine social bonds becomes harder. By 2070, this will be a recognized challenge, and solutions will have emerged. Mandatory in-person gatherings, intentional community spaces, cultural norms around when to use AI mediation, and when to insist on direct human contact. Let's go deeper into how AI will embed itself in daily life. Your grandchildren will wake up to systems that have already optimized their schedules, prepared summaries of information they need for the day, adjusted home temperatures and lighting, perhaps even suggested meals based on health data and preferences. As they move through the day, AI will anticipate needs, flagging important messages, filtering irrelevant information, handling routine decisions automatically. Navigation will be seamless. Entertainment will be hyper-personalized. Shopping will be predictive. AI systems will know what you need before you do. This sounds convenient, and it is, but it also raises questions about autonomy and skill atrophy. If AI handles all routine decisions, do we lose the capacity to make them ourselves? If systems always show us exactly what we want to see, do we lose serendipity, the accidental discoveries that spark creativity? If we never get lost because navigation is perfect, do we lose the spatial awareness that comes from finding our own way? By 2070, these will be recognized concerns, and counter movements will exist. Just as some people today choose analog experiences, vinyl records, paper books, handwritten letters, people in 2070 will cultivate analog mental practices, deliberate disconnection, manual tasks, unoptimized experiences, not as rejection of technology, but as balance, maintaining human capacities that risk atrophy in an AI-saturated environment. Now the uncomfortable question: ethics. By 2070, AI will make decisions that profoundly affect human lives. Who gets loans? Who gets hired? Who gets medical treatment? How resources are allocated? Even aspects of criminal justice. These systems can be faster and more consistent than humans, but they also embed the biases present in their training data. If historical lending data reflects discrimination, an AI trained on that data will perpetuate it unless carefully designed not to. By 2070, robust frameworks for AI ethics will exist, but they'll be imperfect and contested. Who decides what an AI should optimize for? Efficiency? Fairness? If those conflict, which takes priority? Who has the right to know when they're interacting with AI versus human? Who owns the data that AI systems learn from? These are already active debates, and by 2070, they'll have partially resolved into legal and cultural norms. But those norms will vary by region and continue evolving. One area where AI will have made extraordinary progress by 2070 is scientific research. AI systems are already discovering new materials, identifying drug candidates, optimizing industrial processes, and finding patterns in data too complex for human minds to process. By 2070, most scientific research will involve human-AI collaboration, where AI generates hypotheses and identifies promising directions, while humans provide creativity, intuition, and judgment about which questions matter and why. This could accelerate progress dramatically. Climate solutions, medical breakthroughs, energy technologies, materials science, all could advance faster with AI assistance. Your grandchildren may live in a world where problems we consider intractable today have been solved not by human genius alone, but by human-AI partnership. But here's the central paradox of the intelligence revolution. As AI becomes more capable, the uniquely human qualities become more valuable, not less. Empathy can't be automated. Ethical judgment in truly novel situations can't be reduced to algorithms. The ability to ask new questions, to imagine possibilities that don't exist, to find meaning and purpose, these remain fundamentally human. By 2070, education will have shifted to reflect this. Instead of focusing primarily on knowledge transmission, which AI handles effortlessly, education will emphasize creativity, critical thinking, emotional intelligence, collaboration, adaptability, and ethical reasoning. These are the skills that can't be automated, the capacities that make us irreplaceable even in a world of intelligent machines. There's also the question nobody quite knows how to answer. Will AI become conscious? By 2070, we'll likely have systems that appear conscious, that can hold sophisticated conversations, express what seem like emotions, claim subjective experiences. Whether those systems actually have inner experience or merely simulate it convincingly will remain philosophically contested. And practically, it may not matter. If an AI system convincingly expresses pain, should we ignore it because we're uncertain whether it really feels pain? By 2070, these won't be abstract philosophy seminar questions. They'll be urgent ethical and legal issues. Here's what your grandchildren almost certainly won't face, despite decades of speculation. Superintelligent AI that transcends human control and remakes the world according to its own inscrutable goals. Not because it's impossible, but because the path to advanced AI appears to be incremental, specialized systems that excel at specific tasks rather than general intelligence that suddenly awakens. By 2070, AI will be extraordinarily powerful, but still fundamentally a tool shaped by human choices, constrained by design, aligned with human values through careful engineering. The intelligence revolution by 2070 won't be about machines replacing humans. It will be about the emergence of hybrid intelligence, humans and AI working together, each contributing what they do best. The systems will handle information processing, pattern recognition, optimization, routine decisions. Humans will provide goals, meaning, ethics, creativity, and the judgment that comes from embodied experience in a messy, ambiguous world. Your grandchildren will think with AI the way you think with language, so naturally that it becomes invisible, an extension of cognition itself. They won't remember a time before that capability, just as you don't remember learning to speak. And because of that partnership, they'll be capable of things we can barely imagine, solving problems we consider impossibly complex, creating art and music and literature that blends human intuition with machine-generated possibilities, making decisions informed by vastly more information than any human could process alone. But they'll still fall in love, still feel grief, still wonder about their place in the universe, still need companionship and purpose and beauty. The intelligence revolution will change how they think, but not whether they're human. That remains constant, even in a world unrecognizable to us. By 2070, the entire energy infrastructure that powered the 20th century will be museum pieces or still contested ground, depending on choices made in the next 2 decades. The world your grandchildren inherit will run primarily on renewable energy, possibly supplemented by fusion power, with transportation networks that look nothing like the highways and airports we know today. But the transition will be neither smooth nor complete, and the question of whether we reach true carbon neutrality by then remains genuinely uncertain. Let's start with the energy revolution, because everything else depends on it. Solar and wind power have already crossed a threshold that changes everything. They're now the cheapest sources of new electricity generation in most of the world. Not subsidized, not in idealized conditions, actually cheapest. A decade ago, this seemed impossible. Today, it's reality, and costs continue falling. Between 2010 and 2020, the cost of solar photovoltaic electricity dropped by around 85%. Wind dropped by around 50%. These trajectories continue. By 2070, the vast majority of electricity generation globally will come from renewables, dominated by solar and wind. This isn't prediction based on hope. It's extrapolation of existing economic trends. Solar panels will cover rooftops, parking lots, agricultural land in dual-use arrangements where crops grow beneath elevated panels. Wind turbines will dot landscapes and float in deep water offshore. The grid itself will look fundamentally different, decentralized, with energy flowing in multiple directions as buildings and vehicles generate as well as consume power. But renewables have a problem: intermittency. The sun doesn't always shine. The wind doesn't always blow. This requires either massive energy storage or dispatchable power sources that can ramp up when renewables drop. By 2070, both solutions will be deployed at scale. Battery technology, already improving rapidly, will reach energy densities and costs that make grid-scale storage economical. Not just lithium-ion, but next-generation technologies, solid-state batteries, flow batteries, perhaps even technologies we haven't invented yet. These batteries will store excess solar and wind energy during peak production and release it when needed. The other piece of the puzzle is something that sounds like science fiction, but may be reality by 2070. Commercial fusion power. Nuclear fusion, the process that powers the sun, fusing hydrogen atoms into helium and releasing enormous energy, has been 30 years away for the past 60 years. But something changed recently. In December 2022, scientists at the National Ignition Facility achieved fusion ignition, more energy out than in, for the first time in history. Private companies are now racing to commercialize fusion, with some claiming operational plants by the 2030s. Will fusion be a major power source by 2070? Honestly, it's uncertain. The physics works. The engineering is extraordinarily difficult. But if even a fraction of current efforts succeed, fusion could provide abundant, carbon-free baseload power with no meltdown risk and minimal radioactive waste. It could be the missing piece that allows full decarbonization of heavy industry and provides the dispatchable power that complements intermittent renewables. Your grandchildren may live in a world powered by artificial suns, or fusion may remain perpetually 10 years away. We'll know within the next 2 decades. Now let's talk about transport, starting with personal vehicles. By 2070, the internal combustion engine will be a rarity on roads. Electric vehicles will dominate, but not in the form of individually owned cars sitting idle 95% of the time. The model shifting into place is mobility as a service. Fleets of autonomous electric vehicles, summoned by app, arriving within minutes, optimized for efficiency rather than ownership. This transforms urban planning. When you don't need to park, you reclaim enormous amounts of urban land. When vehicles drive themselves, transportation becomes accessible to people who can't drive, children, elderly, disabled. When fleets are shared, vehicle numbers drop dramatically, while mobility increases. This isn't universal by 2070. Rural areas will still rely on personal vehicles. Wealthy individuals will still own cars for pleasure. But in urban centers, where most people live, car ownership will become increasingly uncommon, especially among younger generations who've grown up with seamless mobility services. Your grandchildren may never learn to drive, not because it's illegal, but because it's unnecessary. Intracity travel will transform in more dramatic ways. Several cities are developing tube-based rapid transit systems, enclosed vacuum or near vacuum tubes, where magnetic levitation propels pods at speeds up to 700 miles per hour or more. The Hyperloop concept, once dismissed as fantasy, is being piloted in multiple countries. If these systems prove viable and economical, travel between cities within a few hundred miles could become faster by ground than by air. Los Angeles to San Francisco in 30 minutes. London to Edinburgh in 40. This would reshape commuting patterns, making it feasible to live in one city and work in another. Aviation faces a harder problem. Batteries don't yet have energy density sufficient for long-haul flight. By 2070, short-haul flights, Anything under a few hundred miles will likely be electric or hybrid electric. Regional airports will buzz with quiet electric aircraft ferrying passengers between nearby cities. But long-haul aviation will probably still rely on liquid fuels. The question is, which fuels? Sustainable aviation fuel, synthesized from captured carbon dioxide and renewable electricity, is technically viable but currently expensive. By 2070, if carbon pricing or regulations make fossil jet fuel uneconomical, synthetic fuels could power long-haul flight without net carbon emissions. Or hydrogen fuel cells might mature enough for aviation. Or we might still be burning kerosene, pushing aviation into one of the last holdout sectors for fossil fuels. Then there's space. This seems tangential, but it's not. By 2070, space travel will likely be accessible to far more people, though still expensive. Reusable rockets, pioneered by companies like SpaceX, have already slashed launch costs by an order of magnitude. That trend continues. By 2070, orbital flights for tourism, research, and industrial purposes will be routine. Whether true mass space tourism emerges, thousands or millions of people experiencing orbital flight, depends on costs dropping another order of magnitude. It's possible, but not certain. More significantly, space-based solar power could become reality by 2070. The concept is straightforward. Massive solar arrays in orbit collect sunlight 24 hours a day without atmospheric interference and beam energy to Earth via microwaves or lasers. This sounds wild, but the physics is sound, and several countries, notably Japan and China, are actively researching it. If achieved, space-based solar provides constant baseload renewable power, solving the intermittency problem without batteries or fusion. Whether this happens by 2070 depends on launch costs and engineering breakthroughs, but it's plausible enough to mention. Back on Earth, ground transportation will see a renaissance of rail. High-speed rail networks will expand dramatically, especially in Asia and Europe. Travel between major cities at speeds of 200 to 300 miles per hour will become standard, often faster and more convenient than flying when accounting for airport time. The United States, long resistant to passenger rail, may finally build serious high-speed networks by 2070, driven by climate policy and the economics of electric rail versus other modes. Freight transport faces different challenges. Trucks, ships, and planes move enormous amounts of goods, and decarbonizing this is difficult. Electric trucks are viable for short to medium distances and will be common by 2070. But long-haul trucking may require hydrogen fuel cells or synthetic fuels. Shipping, which moves 90% of global trade, is exploring multiple solutions. Wind-assisted propulsion, using modern sails or rotor sails, hydrogen or ammonia fuel, synthetic fuels, perhaps even nuclear power for the largest vessels. By 2070, the container ships plying oceans will run on some combination of these, though the transition will be incomplete and contested. Now the uncomfortable question: will we actually reach carbon neutrality by 2070? Under current policies, no. We're not even on track for 2050, let alone 2070. But policy changes rapidly, technology advances, economics shift. If the cost of renewables continues falling, if fusion becomes viable, if carbon pricing spreads globally, if public demand for climate action intensifies, all plausible, then genuine carbon neutrality by 2070 is achievable. Not easy, not inevitable, but possible. What does carbon neutrality actually mean? Not that we emit zero carbon. That's impossible. Agriculture, Some industrial processes, aviation, will likely still emit, but those emissions are balanced by carbon removal through reforestation, soil carbon sequestration, direct air capture technologies that pull CO2 from the atmosphere and store it underground. By 2070, carbon removal will be a major industry, operating at scales hard to imagine today. Billions of tons of CO2 extracted annually, stored permanently in geological formations or mineralized into stable carbonates. This technology exists today in pilot form. By 2070, it will be industrial scale, though whether it's sufficient to offset remaining emissions depends on how aggressively we deploy it. There's also the question of legacy infrastructure. Right now, globally, we're still building fossil fuel infrastructure. Power plants, pipelines, refineries designed to operate for decades. Every new piece of fossil infrastructure locks in future emissions. By 2070, the infrastructure built today will still be operating or will have been retired early at enormous financial cost. This creates inertia. The faster we stop building fossil infrastructure, the easier the 2070 energy landscape becomes. The longer we continue, the harder. Here's what's almost certain. By 2070, fossil fuels will provide a much smaller share of global energy than today. Instead of around 80%, perhaps 20 or 30%, concentrated in hard-to-decarbonize sectors. Renewables will dominate electricity. Electric vehicles will dominate roads. Efficiency improvements will mean we use energy far more intelligently. Buildings that generate more power than they consume. Industrial processes that waste minimal heat. Transportation systems optimized for energy efficiency. Your grandchildren will grow up in a world where clean energy is cheap, abundant, and unremarkable. They'll charge vehicles overnight when wind power is strongest. They'll live in homes that manage energy automatically, selling excess solar power to the grid, drawing power during cloudy periods. They'll travel in vehicles that produce no local pollution. They may never see a coal plant in operation, never smell diesel exhaust in city centers, never experience the smog that choked 20th century industrial cities. But they'll also inherit the consequences of our emissions. Even if we reach carbon neutrality by 2070, atmospheric CO2 concentrations will remain elevated for centuries. The climate will continue changing for decades after emissions stop. The ocean will keep rising, ecosystems will keep shifting, weather patterns will keep intensifying. Carbon neutrality by 2070 prevents catastrophic futures, but doesn't restore the past. The planet their children inherit will still be warmer, more volatile, more challenging than the one we grew up on. Here's the paradox. The energy transition is both inevitable and insufficient. Inevitable because economics and technology are driving it regardless of policy. Insufficient because even the fastest plausible transition doesn't prevent significant climate change. It just prevents the worst scenarios. This is the reality your grandchildren will navigate, a world powered by clean energy, but still dealing with the climate consequences of the carbon we're emitting right now. The dream of carbon neutrality by 2070 is achievable. Whether we achieve it depends on choices made in the next 2 decades. Choices about investment, policy, technology deployment, and political will. The tools exist. The economics increasingly favor it. The question is whether we move fast enough. By 2070, we'll know the answer. Your grandchildren will live in the world that answer created. By 2070, the boundary between healing and enhancement, between therapy and transformation, between the body we're born with and the body we choose to inhabit, will have blurred almost beyond recognition. Your grandchildren will live longer, healthier lives than any generation in human history. They'll likely never experience diseases that terrified previous generations. They'll have bodies that repair themselves in ways we can barely imagine. But they'll also face questions about human nature, identity, and fairness that previous generations never had to answer. Let's start with the most straightforward prediction: life expectancy. In developed countries by 2070, life expectancy at birth will likely reach 90 years for women and 86 for men, possibly higher. This isn't speculation. It's extrapolation of trends that have held for more than a century. Since 1840, life expectancy in the longest living populations has increased by about 3 months every year. Barring catastrophic disruptions, this continues. Your grandchildren born around 2050 could routinely live past 100. Some will see 20 to 150. But longevity alone misses the deeper transformation. What matters isn't just living longer, it's living healthier longer. The concept is called health span, the portion of life spent in good health rather than managing chronic illness. Right now, in many developed countries, people live their final decade or more in declining health. By 2070, that compresses dramatically. Medical advances will push the onset of frailty later and later, so people remain vigorous well into their 80s or 90s, then decline relatively quickly at the end. Long life becomes quality life. How? Through multiple converging technologies. Start with genomics. The human genome was first sequenced in 2003 at a cost of about $3 billion. Today, you can sequence your genome for a few $100s. By 2070, everyone will have their genome sequenced at birth or even before birth. That genetic information will guide medical care throughout life, identifying disease risks early, tailoring medications to individual genetic profiles, avoiding treatments that won't work for your particular biology. This is called precision medicine, and by 2070, it will be standard. No more prescribing medications based on population averages and hoping they work. Instead, treatments optimized for your specific genetic makeup, metabolism, and disease state. Cancer therapy is already moving this direction. By 2070, most medicine will operate this way. The result? Far more effective treatments with fewer side effects, catching diseases earlier when they're more treatable, preventing conditions before they develop. Then there's gene therapy, actually editing genes to correct genetic diseases. This technology exists today in early forms. By 2070, thousands of genetic conditions that currently have no cure will be treatable or preventable. Sickle cell disease, cystic fibrosis, Huntington's disease, certain forms of muscular dystrophy. These could be eliminated, either by fixing the genes in affected individuals or preventing transmission to the next generation. Your grandchildren may be the first generation in human history where genetic disease becomes rare. But gene editing raises profound ethical questions that will still be debated in 2070. If we can edit genes to cure disease, can we edit them to enhance traits, higher intelligence, better athletic ability, different physical features? Where's the line between therapy and enhancement? Who decides? What happens to equality when genetic modification is available but expensive, creating a biological divide between those who can afford enhancement and those who can't? By 2070, societies will have developed different answers to these questions. Some countries will permit extensive genetic enhancement. Others will restrict editing to clear medical needs. There will be no global consensus. This creates uncomfortable possibilities. Genetic tourism, where people travel to jurisdictions with looser regulations. Genetic inequality between nations. Social tensions around modified versus unmodified humans. These aren't hypothetical concerns. They're emerging now and will intensify by 2070. Let's talk about specific diseases. Which ones will your grandchildren never experience? Many cancers will be either preventable or highly treatable by 2070. We're already seeing this trajectory. Cancer death rates in developed countries have been falling for decades as screening improves, treatments advance, and prevention becomes more targeted. By 2070, cancer may transition from often fatal to mostly manageable chronic condition, like diabetes is today. Some cancers will be eliminated entirely through vaccination or early genetic intervention. Cardiovascular disease, currently the leading cause of death globally, will decline dramatically. We already know how to prevent most heart disease, control blood pressure, manage cholesterol, maintain healthy weight, exercise, don't smoke. By 2070, medication and monitoring will be far more sophisticated, catching early signs years before symptoms appear. Regenerative therapies may repair damaged heart tissue. Artificial hearts and organs will be far more advanced. Heart disease won't disappear, but it will kill far fewer people. Neurodegenerative diseases, Alzheimer's, Parkinson's, ALS, are the great challenges. We don't yet fully understand their mechanisms, and they've proven difficult to treat. But by 2070, decades of research will likely have produced real therapies. Maybe not cures for everyone, but treatments that slow or halt progression, preserve cognitive function, maintain quality of life. The aging brain will remain vulnerable, but not inevitably doomed to decline. Infectious diseases face a more complex future. Antibiotics are becoming less effective as bacteria evolve resistance. By 2070, we may have moved beyond traditional antibiotics to new approaches, bacteriophages that target specific bacteria, CRISPR-based antimicrobials, immune system enhancements that help bodies fight infections naturally. Or we may be struggling with resistant infections more dangerous than today's. This genuinely could go either way, depending on choices made in the next decade about antibiotic use and research investment. Pandemics will remain threats. COVID-19 demonstrated that even with advanced medicine, novel pathogens can still cause global disruption. By 2070, surveillance will be better, vaccine development faster, response more coordinated. But viruses evolve, and the risk never disappears. Your grandchildren will likely experience pandemics. Whether those are managed quickly or spiral into crises depends on infrastructure, cooperation, and luck. Now let's go deeper into biotechnology. By 2070, regenerative medicine, growing or printing replacement organs and tissues, will transform surgery and transplantation. Need a new kidney? Grow one from your own cells so there's no rejection. Damaged liver? Regenerate it using stem cell therapy. Lost a finger in an accident? Regrow it over months. This sounds like science fiction, but the basic science is already established. By 2070, it's engineering and refinement. Stem cell therapies will be routine by 2070. Stem cells can differentiate into any cell type, meaning they can repair almost any damaged tissue. Right now, stem cell treatments are experimental for most conditions. By 2070, they'll be standard for spinal cord injuries, heart damage, liver failure, joint degeneration. The body's capacity for self-repair, which declines with age, will be artificially restored. There's also tissue engineering, literally building biological structures in labs. Artificial skin, blood vessels, even simplified organs can be grown today. By 2070, fully functional lab-grown organs may be available for transplant. This solves the organ shortage crisis and saves millions of lives. It also raises questions about enhancement. If you can grow a better heart than the one you were born with, should you? Will athletes replace healthy organs with engineered superior versions? Where are the ethical boundaries? The microbiome, the trillions of bacteria and other microorganisms living in and on your body, will be understood far better by 2070. We're only beginning to realize how profoundly the microbiome affects health. Digestion, obviously, but also immune function, mental health, metabolism, possibly even behavior and personality. By 2070, manipulating the microbiome will be standard medicine. Personalized probiotic therapies, fecal transplants refined into precise treatments, dietary recommendations based on your specific gut bacteria. Mental health treatment will transform. Right now, psychiatric medication is crude. Try this drug. If it doesn't work, try another. Adjust doses. Hope for improvement. By 2070, we'll understand brain chemistry far better. Mental health medications will be personalized like all medicine, targeted to individual brain chemistry. Neurotechnology, brain stimulation, neural interfaces will treat depression, anxiety, PTSD more effectively. Therapy will be enhanced by AI tools that help therapists understand patients better and track progress more precisely. There's also the possibility, controversial, still speculative, but plausible, of brain-computer interfaces becoming common by 2070. Not just medical devices for paralysis patients, but enhancements that expand memory, enable direct communication between brains and computers, perhaps eventually between brains directly. This sounds extreme, and widespread adoption by 2070 is uncertain. But early versions exist today, and development is accelerating. Your grandchildren may routinely interface their thoughts with technology in ways that seem invasive or impossible to us. Agriculture will be transformed by biotechnology. By 2070, genetically modified crops will be ubiquitous, engineered not just for pest resistance, but for nutrition, climate resilience, reduced water needs, ability to grow in marginal soils. As global population approaches 10 billion and climate change stresses agriculture, biotechnology will be essential for feeding everyone. Cultured meat, grown from cells without raising and slaughtering animals, will likely be common by 2070, reducing environmental impact and addressing ethical concerns about factory farming. But the most profound shift may be psychological. For all of human history, the body we were born with defined our possibilities. Tall or short, strong or weak, healthy or sick, long-lived or short-lived, these were mostly fate. By 2070, that's no longer true. The body becomes, to a significant extent, a choice. You can modify your genes, grow new organs, enhance your capabilities, extend your life. This is liberating and destabilizing simultaneously. When biology becomes engineered, what happens to human identity? If you replace most of your organs over a lifetime, are you still the same person? If your genes are edited, your brain enhanced by technology, your lifespan extended decades beyond natural limits, what does it mean to be human? These aren't abstract philosophy questions by 2070. They're lived experiences your grandchildren will navigate. There will be resistance, Not everyone will embrace biological modification. Religious, cultural, and personal values will lead many to reject enhancement technologies even when available. This could create social divisions: modified versus unmodified, enhanced versus natural, long-lived versus normal lifespan. Managing these tensions while preserving freedom of choice will be an ongoing challenge. The economic questions are immense. These technologies will initially be expensive, accessible mainly to wealthy countries and wealthy individuals. This could exacerbate global inequality, the rich living longer, healthier lives, while the poor die younger of treatable conditions. Or, medical technologies historically follow a pattern: expensive at first, then dropping rapidly in cost as they scale. The smartphone in your pocket has computing power that cost millions a few decades ago. Medical technologies could follow the same trajectory, becoming accessible globally by 2070. Which path we follow depends on policy choices about intellectual property, healthcare systems, global cooperation. Here's what's clear. By 2070, the biological frontier will have expanded in ways that challenge our current understanding of medicine, health, and human nature itself. Your grandchildren will live in bodies that are healthier, longer lasting, and more modifiable than ours. They'll likely never experience many diseases we still fear. They'll have tools to shape their own biology in ways we're only beginning to imagine. But they'll also inherit the responsibility of using those tools wisely. The power to extend life, cure disease, and enhance capability comes with questions about fairness, identity, limits, and what kind of creatures we want to become. These questions have no single answer. They'll be debated, contested, and resolved differently across cultures and generations. The biological frontier opens. By 2070, your grandchildren will live on the other side of it, in bodies and with capabilities that would seem miraculous to us. But they'll still be human, still vulnerable, still mortal eventually, still seeking meaning, connection, and purpose. Technology changes the body. The questions of how to live, why to live, what makes life worthwhile, those remain eternally human, no matter how much biology we engineer. We've walked through 7 transformations: climate thresholds crossed, populations aging and shifting, cities reimagined, coastlines redrawn, intelligence augmented, energy systems rebuilt, and biology itself becoming engineered. Each change alone would mark an era. Together, they represent something unprecedented: the compound transformation of nearly every system that defines human life on Earth. By 2070, your grandchildren will inherit a planet so profoundly altered that calling it Earth will require a mental asterisk. Yes, the same place, but fundamentally reconfigured. So here's the question that underlies everything we've discussed. When so much changes, what remains? What persists across these transformations that still makes us recognizably human? The answer matters, because it determines not just how we adapt to 2070's world, but whether that adaptation preserves what makes human life meaningful. We can survive enormous change. History proves that. We've survived ice ages, plagues, wars, technological revolutions, but survival alone isn't the goal. The goal is to remain fully human, capable of joy, connection, meaning, purpose, in circumstances our ancestors couldn't imagine. Let's synthesize what we know. By 2070, the planet will be 1.5 to 2 degrees warmer than pre-industrial levels, with that heat locked in, regardless of what we do now. 3 billion people will experience unprecedented heat stress. Sea levels will have risen enough to displace millions and remake coastlines. Arctic summers will be ice-free. Ecosystems will have shifted, with some species extinct and others migrating to new ranges. This isn't speculation. This is physics and biology playing out with mathematical precision. Simultaneously, human populations will have fundamentally restructured. Europe will be older, smaller, more immigrant-influenced. Africa will be younger, larger, increasingly urbanized. Asia will see the world's largest economies grappling with shrinking workforces. The global population will peak somewhere around 10 billion and begin the slow decline that demographers call the Great Contraction. Humanity will be living longer, routinely past 90, sometimes past 100. But in societies where the old vastly outnumber the young, raising questions about dynamism, innovation, and how to care for unprecedented numbers of elderly. Cities will have compressed their footprints while increasing density, becoming walkable, green, energy-efficient networks where cars are rare and public space abundant. Or they won't have. And they'll be struggling with sprawling, car-dependent infrastructure they can't afford to maintain. The fork in that road happens in the next decade. By 2070, we'll be living with the consequences of choices made right now about urban form. Technology will be so embedded in daily life that distinguishing between human and machine intelligence becomes nearly meaningless in practice. AI will handle vast amounts of routine cognitive work, freeing humans for creativity, judgment, and connection, or displacing them into economic uncertainty if we fail to manage the transition. Work will be distributed, often remote, frequently automated, sometimes unrecognizable compared to today's employment. The question of what humans do when machines can do so much will have been partially answered, though never fully settled. Energy will come primarily from renewables, solar, wind, perhaps fusion, with fossil fuels relegated to niche applications or banned entirely, depending on how aggressively climate policy evolves. Transportation will be electric, shared, increasingly autonomous. Long-distance travel by hyperloop or high-speed rail. Aviation struggling with decarbonization. Space more accessible, but still expensive. The carbon intensity of daily life will have dropped dramatically, though not to zero, and not fast enough to prevent significant climate change. And biology will have become malleable, genes edited to prevent disease, organs grown in labs, lifespan extended, mental health treated with precision, bodies enhanced beyond natural limits, or at least the limits we think of as natural. The boundary between therapy and enhancement will be contested, uneven, and culturally specific. Some of your grandchildren will embrace biological modification. Others will reject it on principle. Both will be living in the same societies, navigating the same institutions, raising children together, modified and unmodified, enhanced and natural, long-lived and mortal by choice. That's the world. Warmer, older, denser, smarter, longer-lived, technologically saturated, biologically fluid. Unrecognizable in specifics, but recognizable in outline if you've been paying attention to the trends that got us here. Now, what remains human in all this? Start with the obvious: connection. Humans are social creatures. We survived and thrived, not because we were the strongest or fastest, but because we cooperated, communicated, built communities. That doesn't change in 2070. Your grandchildren will still need friendship, love, belonging, the sense that they matter to someone. Technology can mediate connection, and by 2070, it will mediate more of it. But it can't replace the fundamental need for human contact. The loneliness epidemic we're experiencing now is a warning. When connection becomes too mediated, too virtual, too optimized by algorithms, something essential breaks. By 2070, this will be understood, and cultures will have developed norms around preserving genuine human interaction amid technological saturation. Or they won't, and loneliness will be endemic, one of the great unintended crises of advanced civilization. Curiosity remains. The drive to understand, explore, ask questions, seek meaning. This is fundamentally human. AI can answer questions, but it doesn't ask them. It doesn't wonder why. Your grandchildren will still look at the stars and ask what's out there. They'll still encounter mystery and want to solve it. They'll still create art, not because it's useful, but because something in the human spirit demands expression. Curiosity and creativity can't be automated. They emerge from consciousness, from the strange fact of being a self-aware creature in a universe that doesn't owe you explanations. Mortality remains, even if delayed. No matter how much we extend lifespan, no matter how many organs we replace, no matter how carefully we engineer biology, humans in 2070 will still die. Maybe at 90, maybe at 110, but eventually, inevitably. And that mortality gives life urgency and meaning. If we live forever, would anything matter? The clock ticking in the background, maybe more slowly by 2070, but still ticking, is what makes choices consequential, relationships precious, moments irreplaceable. Your grandchildren will still grapple with mortality, still face grief when loved ones die, still wonder what, if anything, lies beyond. The old questions about meaning, purpose, what makes a life well lived, these persist, unchanged by any technology. Beauty remains. The sunset over rising seas is still beautiful. The way light filters through urban forests and dense, walkable cities is still beautiful. Music, art, literature, the curve of a lover's face, the laugh of a child, these don't become less beautiful because the world has changed. If anything, amid transformation, the human capacity to find and create beauty becomes more important, not less. It's an anchor, a reminder that life isn't just survival and optimization. It's experience, sensation, the pure fact of being alive and capable of wonder. Ethics remain, though the questions become more complex. Is it right to edit a child's genes to prevent disease? What about to enhance intelligence? Who gets access to life extension technology? How do we balance individual freedom with collective welfare in a warming world? What do we owe future generations, the ones who'll inherit the planet we're shaping now? Your grandchildren won't have simpler ethical questions than we do. They'll have harder ones, with higher stakes, more ambiguity, and technology that makes consequences more immediate and irreversible. But the capacity for ethical reasoning, for distinguishing right from wrong, even when it's difficult, remains human. Machines can optimize for goals, but setting goals, deciding what matters, recognizing that some things are sacred, even when inconvenient, that's irreducibly human. Suffering remains, unfortunately. Climate refugees will suffer displacement. People in heat zones will suffer extreme temperatures. Those who can't afford enhancement technologies will suffer inequality. The elderly in societies unprepared for aging will suffer neglect. Suffering can be reduced. That's the whole point of medical and technological progress. But it can't be eliminated. Your grandchildren will still experience loss, pain, disappointment, heartbreak. And in facing suffering, they'll still need resilience, compassion, solidarity. The human capacity to endure and support others through hardship doesn't become obsolete. It becomes more necessary when systems are strained and change is constant. Adaptation remains, and this is crucial. Humans are extraordinarily adaptable. We've thrived in every climate zone on Earth, from Arctic tundra to tropical rainforest to desert to high altitude. We've survived pandemics, famines, wars, economic collapses, technological disruptions. We adapt. Not always gracefully, not always equitably, but we do it. Your grandchildren will adapt to 2070's world the way you adapted to the internet. Smartphones, social media, tools that seemed impossible to your grandparents, but are second nature to you. They'll grow up with AI as ordinary, with edited genes as normal, with climate change as given. What seems overwhelming to us will be their baseline. But here's the paradox. Adaptation is easier when you remember what you're adapting for. If the goal is just survival, just maintaining systems, just optimizing efficiency, then adaptation becomes mechanical. We become cogs, responding to pressure, losing sight of purpose. But if adaptation is in service of human flourishing, preserving what makes life worth living, then it's purposeful. We change the systems that need changing, while protecting the values that define us. So what should your grandchildren preserve as they navigate 2070? What should they fight to keep human? Face-to-face interaction, unmediated by screens or algorithms. Physical presence, the irreplaceable quality of being in the same room with someone you love. Time in nature, even if that nature is radically altered. Forests, oceans, mountains, rivers, the non-human world that reminds us we're part of something larger. Manual skills, the satisfaction of making something with your hands, cooking a meal, building an object, creating without AI assistance. These skills keep us embodied, grounded in the physical world. Boredom and unstructured time, space to think without constant stimulation, to daydream, to let the mind wander. Creativity emerges from boredom. Insight comes from unstructured thought. Stories. Humanity has always been a storytelling species. We make sense of the world through narrative. Your grandchildren will still need stories to understand themselves, their history, their place in the continuum of human experience. Whether those stories are traditional or AI-assisted matters less than that storytelling itself persists. Rituals and traditions that mark transitions, birth, coming of age, marriage, death. These anchor us in continuity, connect us to ancestors, provide structure for meaning. And this, the knowledge that they're part of a long chain, that people before them faced seemingly impossible challenges and adapted, that people after them will face different challenges and adapt differently. That being human has always meant living in uncertainty, making imperfect choices, trying to leave things slightly better than we found them. By 2070, your grandchildren will live in a world we'd barely recognize. But if they're still capable of love, still curious, still finding beauty, still asking why, still showing compassion, still adapting without losing sight of purpose, then they're still human. The external circumstances change. The internal essence persists. We've spent 7 episodes detailing transformations. Here, at the end, is the stability, humanity itself, unchanged in its core, needs, and capacities, even as everything around it shifts. Your grandchildren won't recognize Earth in 2070, but they'll recognize themselves in the mirror. They'll recognize the human condition, the struggle, the joy, the meaning made from chaos, the love that persists despite everything. They'll look back at us, navigating our own crises, and understand that we were human too, doing our best with imperfect knowledge, leaving them a world that's broken in some ways and beautiful in others. And they'll do what humans have always done: adapt, endure, create, connect, and pass it forward. The earth changes. Humanity changes with it. But what makes us human? That remains. In 2070, as now, as always, the future is unrecognizable. Humanity is not.